So we continue our discussion about sets and the concepts of complements, union, intersection, operations, and cardinal number. Sets and precise use of everyday English. Set operations and Venn diagrams provide precise ways of organizing, classifying, and describing the various kinds of sets and subsets we encounter every day. When working with sets, the word "or" refers to the union of sets. So if you have two sets and you want to find the union of the two sets, the union will consist of elements that are in the first set or in the second set. The word "and" refers to the intersection of sets. So if you want to find the intersection of two sets, the elements in that intersection will be the elements that are in the first set and in the second set. So in those areas that overlap in the Venn diagram. So the first one asks us to find the complement of A union B. And the second one asks us to find the complement of A intersected with the complement of B. Since we have parentheses in the first case, we have to find the union first. To find the union of two sets means to find a set that lists the elements that are in both or either set. Our union set, so A union B, we'll do that first, is all of the elements from A and all of the elements from B. I'll try to list them in order. 8 is repeated, but we do not need to write it twice. So in our union, we have the elements 1, 2, 4, 5, 8, 9, and 10. But we're not asked to find just the union, we're asked to find the complement of the union. And remember, the complement of the union are all the elements from the universal set that are not in the other set. So we're looking for the elements from the universal set that are not within this union. So let's see, 1 is in the set, and 2 is in the set, and 4 is in the set. 5, 8, 9, and 10 are in the union. So we've got to find the complement, which would leave us only those elements 3, 6, and 7. In the second one, I need to find the complement of the sets and then find their intersection. So remember, the complement of the set is a set of elements from the universal set that are not in the set itself. So I'll go ahead and write A prime out here. I'm looking for elements in U that are not in A. 1 is such an element. 2 is in set A, so I don't list it. 3, 4 is also in A. 5 is not in A. 6 is not in A. 7 is not in A. 8 is, but 9 is not, and 10 is. So that's my complement of A. Remember, a set along with its complement must make up the universal set. Now let's find the complement of set B. That is B prime. And B prime has to be all of the elements in the universal set that are not in set B. So we don't want to include the 1, the 5, the 8, or the 9, meaning we would include the 2, the 3, the 4, the 6, the 7, the 10. So once again, we want to make sure that we do not include any of the elements that are in set B in its complement. That would leave us with 2, 3, 4, 6, 7, and 10. Now that was just finding these complements, A prime and B prime. Now we have to find the intersection of the complements. And that is, where do these complements overlap? What do they have in common? So we look at the elements in A prime and B prime, and we see that they both have a 3, they both have a 6, and they both have a 7. And that means that our set that makes up A prime intersect B prime is the set 3, 6, and 7. So we'll use this diagram to determine each of the following sets. So the first one is A union B. To find the union of two sets, we find the elements that are contained in either or both sets. Remember, OR is for union. So we need to list those elements from A or B, and they would be 0, E, 8.2, square root of 5, pi, A, -4, and 1/2. So I have listed all of the elements from A, plus the 2 additional elements from B that are not included in A to begin with. So when I'm listing the elements of A union B, there is overlap here in the center section, pi and A, and I don't list those twice. I just list those one time. But we have listed everything that is in set A or in set B or in both, and we did not list the 7 and the 21 because 7 and 21 are in the universal set but not in set A or B. Now part B asks us to find the complement of A union B. And in fact, those are the elements I just mentioned, because remember that the complement means those elements from the universal set that are not in the set that we're talking about. And we're talking about this set A union B, this long set we've just written out, and the only remaining items that would be in the universal set that are not in this set are the 7 and 21. So 7 and 21 is the complement of the union of sets A and B. The third one, part C, asks us to find A intersect B. Remember that the intersection is the set of all elements contained in both set A and in set B, represented on the Venn diagram by the overlapping area. In this case, just 2 elements, pi and A. Part D asks us for the complement of the set we just found, the intersection of A and B. The complement will be all of the remaining elements within the universal set 0E, 8.2, square root of 5, -4, 1/2, 7, and 21. We do have to include the 7 and 21 because to find the complement of a set, we have to find all of the elements in the universal set that are not included in our original set, which was just the set of pi and A. So in our part E, we are asked to find the complement of A intersected with B. We'll first find the complement of A. The complement of A will be the elements from the universal set except those elements that are in A. So I will eliminate all of these elements from set A, that is the 0, the E, the 8.2, the square root of 5, the pi, and the A. Those are all contained within the circle for set A. The complement is the rest of the elements. Those elements are -4, 1/2, 7, and 21. So working here with part E, we're going to intersect this with set B. So I'm going to go ahead and write out all the elements of set B. And from a Venn diagram, we know the elements of set B are all those contained in the circle labeled with the letter B. So when we're asked to find the intersection of these two sets, that is this symbol here, the upside down U, we are looking for the elements that they have in common. You will notice that they have a -4 and a 1/2 in common. And the last set operation we're asked to do in part F is to take set A and find the union with the complement of B, or A union B prime. Now again, let's start by defining B prime. The complement of B consists of all elements from this universal set except those that are in B. So I will mark out the pi and the A, the -4 and the 1/2, and I will list everything else: 0, E, 8.2, square root of 5, 7, and 21. That's my complement of B. I need to find the union of this set with A, which is 0, E, 8.2, and the square root of 5, pi, and A. Remember that set A contains all the elements within the circle labeled A. And the union of these two sets will be all the elements from A or from the complement of B. So let's see if we can list those elements here. Must be an A or B. Well, there's a 0 in A or B. So I'll list the 0. There's an E. I'm just marking it out from the set so I can make sure I've covered it. There's an 8.2. There's a square root of 5. Now remember, it can be in either set or in both sets. And so far, they've been in both sets. But there's also a 7, a 21, a pi, and an A. So that is our set that represents A unioned with the complement of B. In this last example, we're going to talk about the cardinal number of a set, and in specific, the cardinal number of the union of two finite sets. Now, finite simply means that we can list out all the elements of a set. And the cardinal number is the number of distinct elements in a set. Now, the cardinal number of a finite set is found by counting the number of elements in the set. The way we write cardinal number of set A is n of A, that is n with parentheses A, and that does not mean multiplication. It means the cardinal number or the number of elements in set A. Think of it that way. Now, the cardinal number of the union of two finite sets is found by finding the sum of the cardinal number of each of the original sets, but subtracting any elements that are in the intersection. So in other words, if they overlap, you can't count those elements twice. So to find the cardinal number of the union, we first find the cardinal number of each set, then we add those together, but we subtract the number of elements that are in the intersection of the sets. And you can see that written here. The cardinal number, that is the n of the union of A and B, is the number of elements in set A plus the number of elements in set B minus the number of overlapping elements, or the elements in their intersection. So in this example, we'll answer the question by finding the cardinal number of the set. A survey was taken that asked the following questions about the following social network sites. Number 1, do you have a Facebook account? 280 of those surveyed said yes. Question number 2, do you have a MySpace account? And 155 said yes. Question number 3, do you have both a Facebook and a MySpace account? 127 of those surveyed said yes. How many students were surveyed? So each student was asked these 3 questions. So we're going to let set A represent the students who said they have a Facebook account. So within our circle that represents set A, we have to have 280 respondents. We're going to let set B represent the students who said they have MySpace. So within circle B, we have to have 155 respondents. But those that have both accounts will be shown in the overlapped area in the Venn diagram, since they belong to both sets. So we're going to start with this number actually and put it in the overlap area, 127. We can work from that number backwards now and find the remaining elements in set A. So 280 said they have Facebook, but of those 280, 127 also have MySpace. So we don't want to count those students doubly. So we subtract these and we get 153. So in set A, there are 153 that are just Facebook, 127 that are MySpace. So that's a total of 280 for set A. So our set A has 280 total students. The 153 students who have just the Facebook, as well as the 127 students who have both. We can also find the elements of set B. Knowing that we already have 127 included, we have 155 who said that they have MySpace altogether. So 155 subtract 127 will help us to find the remaining elements for B. So that's going to be 28 students. So there are 28 more over in set B. Now just double checking, 153 and 127 make up the elements of set A. If you add those up, you get 280. And set B is 127 from the overlap region and 28. That's 155. And from our picture, we can also see that we have written the 127 in our overlap area. Now this helps us to answer the question about how many people were surveyed. Now, taking what we just learned, we can answer the question of how many students were actually surveyed by looking at either the formula or the Venn diagram that we prepared before. So remember, from the Venn diagram, we had written 127 in our overlapping area, and that meant that there were 153 additional elements in set A, and that there were 28 elements in B. And that would actually be our answer. 153, 127 is the 280, and the 280 plus 28, 308, is actually the number of students surveyed. That's the total. Now, it's not just 280 and 155, because that contains this overlap of 127 in the middle. And you're counting those twice, actually. So our formula for the cardinal number will say, take the cardinal number of set A, or the number of elements in set A, add that to the cardinal number or the number of elements in set B, but subtract out the overlap of 127. So if you take 280, add that to 155, you get a number that's too high because it includes those students with both accounts are being counted twice. So you take the students with both accounts and you subtract out that intersection. That's the last part of our formula. And if you do that, you get the same answer. 308 students were surveyed.